presentation is monitoring chicken farms using rail surveillance system and deep learning.
Good morning, everyone. My name is Kai-Rong Chang, and a student from National Taiwan University. Today, I'm going to present my research monitoring chicken farms using rail surveillance system and deep learning, and my advisor is Dr. Fu. First, I will briefly introduce the background of my research. In Taiwan, chicken industry produces 3.1 billion USD annually and accounting for 46% of total animal husbandry revenue. And in plenty of breeds in Taiwan, Taiwan native chicken is one of the chicken which is famous for its chewy flavor. And this kind of chicken was rearing using a high density method for 12 to 13 weeks. And so farmers spending a lot of time monitoring chicken health and environment for using human patrolling inside the chicken farms. And so due to the labor intensive in chicken farms, so this research aims to propose a smart rail surveillance system monitoring chicken flocks and analyze chicken dispersion and movement in chicken farms for chicken health. And next is my material and method. This is the chicken farm the commercial chicken farm and where this system was located. And the system was hanging on the brown line, which is the rail in the chicken farms. And my system was separated into hardware and software. First, I went to do a smart surveillance module, which is the hardware. And this module was composed of dual channel camera with RGB and thermal channel, and environmental sensor, control box, and motor, and limited switches. And this module was patrolling from 7 a.m. to 7 p.m. with totally within 1.5 hours and totally 6 patrols a day. This module will stop at 9 stop points for 5-minute video recording at each patrol, and the stop point is the yellow spot in the in the picture. And next is my software. This software includes chicken detection model and dispersion quantification algorithm, movement quantification algorithm, and hypothermia detection algorithm, which means in this research I will detect the dead chicken in the image. For chicken detection model, I use 600 annotated images to train a YOLO V9 model. And dispersion quantification algorithm use nearest neighbor index to quantify chicken dispersion in the after detect the chicken in the images. And a multiple movement quantification algorithm, I use a simple online real-time tracking algorithm to quantify chicken movement in the video. And due to the capture range of RGB and thermal channel was different, so I aligned the image of RGB and thermal images using a perspective transform that will align the image just like this. And a color bar was used to detect the temperature in those thermal image and RGB image alignment. And OCR was used to identify the maximum and minimum temperature, and linear interpolation was used to know the temperature of centroid bounding box of chicken. And a dynamic threshold was used to distinguish the dead chicken in the images. Next is my result. And the detection performance of the chicken detection model achieved an AP of 94.3%. And the dispersion quantification results show that when the dispersion was low, the chicken was sparsely distributed, and when the dispersion was close to 1, the chickens were densely distributed. And the tracking performance achieved an overall multiple object tracking accuracy of 93.9%. And for the hypothermal detection result, and in this image, the chicken at lower left was detected as a dead chicken. And those results can be used to analyze the chicken's dispersion, movement, and environmental parameter in daily, hourly, and spatial analysis. And here showing the analysis of the daily analysis, hourly analysis, and spatial analysis. And my conclusion, this proposed system can be used to automatically and objectively help the farmers identify the chicken health in chicken farms. And for future, it can be used to establish a warning system like when the chicken movement or dispersion was high or lower than average, they can call chicken farmers to solve this problem in the chicken farms. And thanks for Ministry of Agriculture in Taiwan for supporting this research. And thanks to Li-Ray for providing the experimental site. Thanks for your attention.
And then I just wonder whether its tracking is working well when the two chickens are merged and then diverge out.
In this video, I show that chicken is not move very fast, but in a fast case, there is still a good tracking in the in the chicken farms. Yeah.
So
And
really
sometimes when the chicken cross by, sometimes they will change their ID because they run too fast and the algorithm cannot track very well in all passing case. Yes.
just wonder this tracking machine learning software can detect a small feature difference between different chickens.
Yes.
Is it easy to register to identify the same chicken between RGB and thermal camera? Because they, for me, in thermal camera, they all look the same.
Because in my research, I use one camera and for 2 channels. So I only use just the image alignment, which aligns the chip and the 2. So I aligned the bounding pass in chickens. We detect in the RGB image and projected the centroid of the result to the thermal trend. So and in this result, I think it's very precise.
So it's already registered?
Yeah.
Calibrated.
Yes.
Thank you. Any other?
Similar success rates as well. So comments and thoughts on that?
In my research, I think it's 94% is enough for me because I detect the chicken movement and dispersion for the whole chickens, and I think 94% is enough for deployment. And I think if you want to improve the precision, I think you can maybe changing some different kind of model because there are a lot of transformers model now for I think one stage for tracking detection to tracking. Maybe it will improve the result.
Thank you. For the time.